Hey guys, Mrs. Hilscher here. So today we're starting geometry. Our first lesson is on lines and angles. Let's first start out with pairs of angles. And remember guys to rewind the video as much as you need to or press pause and take notes. Okay, so there's a couple different types of pairs of angles that we need to know. Our first one is called adjacent angles. Right? Adjacent angles are two angles that share a vertex and share a side, but do not overlap. Okay, so vertex is the point where the two angles meet, and adjacent angles would look like this. Right, so these two angles, we have angle 1 and angle 2. These would be adjacent angles. Angle 1 and angle 2 are adjacent. Alright, the next type is vertical angles. Right, vertical angles are two angles whose sides form two pairs of opposite rays. Sorry about that. Okay, so here we have four different angles. 1, 2, 3, 4. Right? Here we can see that this angle, angle 1, and angle 3, are vertical angles. And also this angle and this angle, angle 2 and angle 4 are also vertical angles. Okay, here's where our first theorem comes in. Okay, we have a theorem about vertical angles. The theorem states, and whenever you see me write THM, that's theorem, which is short for theorem. The theorem states that vertical angles are congruent. Right, and if you remember back from other math classes, congruent means that they are the same measurement. Alright, our next pair of angles is complementary angles. I'm sure most of you remember these, the two angles whose measure add up to 90 degrees. Sorry, that wasn't very straight. So we have two angles here, angle 1, angle 2, and they created a 90-degree angle together. Therefore, they are complementary. The next one goes along with complementary is supplementary. Right? And that's where two angles whose measures add up to 180 degrees, or they create a straight line. So here we have angle 1 and angle 2, and notice together they create a straight line, or 180 degrees. That means the angle 1 and angle 2 are supplementary. Okay, so now those were all the examples of pairs of angles. Now we're going to talk about what is known as a transversal. Okay? A transversal is a line that intersects two or more lines. And remember, when lines intersect, angles are formed in several different locations. Now for the next three theorems that I give you, we are going to look at this picture right here, and I'll redraw it every time. Okay, so here we have two lines that are parallel. We'll call this line L and line M. Right, these are parallel lines. And if you remember, parallel lines are two lines that never intersect. Right, this line right here, we'll call it line E, is cutting through those two lines, or it's intersecting those two lines. Line E is our transversal line. Remember when I said that intersecting lines create angles? Well, let's look at how many angles this transversal created. 1, 2, 3, 4, 5, 6, 7, 8. This transversal cut through the parallel lines and created 8 different angles for us to look at. Okay? So, like I said, there are 3 different theorems about transversal lines and parallel lines. So let's look at the first one. Okay, our first theorem. Okay, so our first theorem says, if two parallel lines are cut by a transversal, the alternate interior angles are congruent. Now let me draw that picture again that I just had. And rewrite in the angles. Okay, so according to this theorem, we have two parallel lines and it's cut by a transversal. It says alternate interior angles are congruent. Alternate interior angles are angles that are on opposite side of the transversal and are on the inside of the parallel lines. So for example, 3 and 6 are alternate interior angles. They're on opposite sides of the transversal line and they're on the inside of the parallel lines. So angle 3 is congruent, and that's what this little symbol means, to angle 6. Angle 3 and angle 6 are congruent because they are alternate interior angles. Same for angle 5 and angle 4. They are also congruent. Alright, our second theorem . Our second theorem states, if two parallel lines are cut by a transversal, the alternate exterior angles are congruent. Right, so looking at our picture again. Oops, wrong line. Looking at our picture again with our angles. Alternate exterior angles are the angles that are on opposite side of the transversal but are on the outside of the parallel lines, the exterior of the parallel lines, if you will. So for this, angle 1 and angle 8 would be an example of alternate exterior angles. So angle 1 is congruent to angle 8. Same for angle 2 and angle 7. They are also congruent. Alright, so our third theorem Okay, so our third theorem, if two parallel lines are cut by a transversal, the corresponding angles are congruent. So again, let me draw our picture. That wasn't very parallel. Okay, corresponding angles. Corresponding angles are angles that are in the same position. So take 1 and 5. 1 and 5 are both on the left side of the transversal, and they're both on top of a parallel line. So there are many corresponding angles here. So angle 1 is congruent to angle 5. Angle 3 is congruent to angle 7, because angle 3 and angle 7 are both on the left side of the transversal, and they're underneath the parallel lines. So we just go ahead and write out the rest of them. 2 and 6, 4 and 8. Alright, so let's look at an example of how to use these three theorems. I'm going to redraw that picture. Okay, This time, I'm going to tell you that the measure of angle 1 equals, let's go with 100 degrees. Okay? So that's what the M stands for, measure. Measure of angle 1 equals 100 degrees. Okay? By giving you this one angle, you should be able to tell me what every single other angle on this board is. Okay? So I want you to pause the video, and I want everybody in the class to figure out the measures of angles 2 through 8. Okay, so now that you've done that, let's go over them together. So, I'll write them over here. Pen isn't working. Sorry about that. Okay, so if the measure of angle 1 is 100 degrees, then we need to use our three theorems to figure out which one of these angles are congruent to angle 1 as well. Okay, so we have angle 1 and angle 8 are congruent because they are alternate exterior angles. So we know this is 100 degrees. Okay. We know that angle 1 and angle 5 are corresponding angles, so they're congruent. So angle 5 is also 100 degrees. And we also know from our very first theorem that angle 1 and angle 4 are congruent. Now why is this? Because angle 1 and angle 4 are vertical angles. Okay, we could have also figured that out because 5 and 4 are congruent because they're alternate interior angles. Okay, and also 8 and 4 are corresponding angles. Alright, so now let's look at angle 1 and angle 2. They created a straight line. Okay, we know that if it's a straight line, it has to be 180 degrees. Okay, so then we do 180 minus our angle 1, 100, and we get 80 degrees. So that means that angle 2 is 80 degrees. Right? Then that tells us that 2 and 6 are corresponding angles, so they're congruent. Two and 7 are alternate exteriors, so they're congruent. 6 and 3 are alternate interior, so they're congruent. So see, if we have one angle out of the 8, we can find all the rest using those theorems. Alright, that's it for this lesson.